Guys, last new lesson in this unit, we're going to talk about geometric sequences. It is technically our fourth lesson in this unit, so 7.4, but in your textbooks, if you need more references, it is 9.8. Okay. So today you're going to learn how to recognize what a geometric sequence is and write an equation for that sequence. So let's just review arithmetic sequences for a minute. Arithmetic sequences are sequences where we add a common ratio. Okay. And so it might be something like 3, 7, 11, 15, 19. We're adding 4 each time, right? So we added 4. And we had a formula that if we wanted to find the nth term, we said that we took the first term plus the number of terms minus 1 times the common difference. So in this case, my first term was 3. My common difference was 4 because we added 4 each time. So the basic formula, remember, would have been a sub n equals 3 plus n minus 1 times 4. Okay, and we could have divided if we wanted, or distributed if we wanted, or we could have just left it like this. And then if I wanted to say, find the 15th term, okay, I would just plug in 15. So 3 plus 15 minus 1 times 4. So 3 plus 14 times 4. And 14 times 4 is 56. So 3 plus 56. So my 10th term was 59. And we're going to do something really similar, but this time we're going to talk about with geometric sequences. And geometric sequences are found by multiplying the previous term by a constant rate or ratio. Okay. And we call that the common ratio. So if I look at my first sequence, 1, 3, 9, 27, I can see that I multiply each term by 1. By 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So this is a geometric sequence. Okay. Here, in my second example, and the way we can check to see is we can do some division if we wanted to. We can do 15 divided by 20. And 15 divided by 20 is going to give us 3/4. So then we could multiply each term by 3/4 and see if we get that. We're not going to. We're going to, this is arithmetic because I'm adding 5 each time. Okay, so that is geometric. If I look at this, 2 times 4 gives me 8, but 8 times 4 is not 14, so that's not geometric. Example 4, it's 100 divided by 2 gives me 50, divided by 2 gives me 25, divided by 2 gives me 12.5. And remember, dividing by 2 is the same as multiplying by 1/2. So this is a geometric sequence, and our ratio in this case is 1/2. And that's fine. Okay. So let's find the common ratio and then find the next 3 terms of the following geometric sequences. So 15 divided by -3 is -5. So I think that my common ratio is -5. And I'm going to double check that by multiplying each of these by 15. So if I do that, 15 times -5 is -17, or -75. Okay, so 15 times -5 is -75. Okay, so we know that it's going to work. So to find my next 2 sequences, this should be plus 375. Okay, I'm going to multiply by -5. So 375 times -5 is -5. 1,875. And then I'm going to take that and multiply by -5. And that's going to give me, I'm going to erase this real quick, 9,375. So those are my next two sequences. When I look at the next one, that doesn't look as easy. So what I'm going to do is I'm going to divide 36 divided by 24, and that's going to give me 1.5. So 36 divided by 24 equals 1.5. So our ratio is 1.5. So I'm going to multiply each next term by 1.5. So 81 times 1.5 is 121 and 5/10. That times 1.5 is 182 and 25/100. So those are my next, well, I want 3, so I'm going to multiply that one more time. And I'm going to get 273.375 thousandths. So that's how I would generate some more terms. Now, just like with arithmetic sequences, we have a general formula for arithmetic. A sub n, remember, means any term. N is our number of terms. A sub 1, just like before, is our first term. And R is our common ratio, what we multiplied or divided by. So let's look at some examples. Okay, I want to write an equation for the nth term of the sequence. So it's A sub n equals A sub 1 times R to the n minus 1 power. So if I look at this, this should be -48. Okay. I'm going to multiply everything by 2. That's my common ratio. -12 divided by -6 is 2. So my R is 2, and my A sub 1 is -6. So my basic formula for any term is A sub n equals -6 times 2 to the n minus 1. And that's all there is to it. Okay. Let's try this one. I'm not sure, looking like my R is a little harder to find. So if I do 48 divided by 96, I'm going to get my R to be 1/2 or 0.5. And I got that, remember, by 48 divided by 96. So again, any term is equal to the first term times R to the n minus 1. And in this case, A sub n equals 96 times 0.5 to the n minus 1. And we're done. That's all you have to do. So now we know that the first term of a geometric sequence is 1 and the common ratio is 9. What is the 10th term of the sequence? So again, any term is equal to the first term times the common ratio to the n minus 1 power. So let's just write the common equation first. So A sub n is going to equal 1 times 9 to the n minus 1. So if I want to find the first term, or the 10th term, I'm going to plug in 10 for n. 1 times 9 to the 10 minus 1. Okay, 10 minus 1 is 9. Using order of operations, we're going to do 9 to the 9th first. And that's going to give me a really large number. 387420489. So it's going to give me 387,420,489. And it's 1 times that, so it's just going to give me that same answer. So let's actually, well, look at which of these following we think are geometric or arithmetic, or neither. I'm multiplying this 2 times 2 gives me 4, but 4 times 2 does not give me 16, so that's going to be neither. This one actually is geometric because I'm multiplying each time by -1. I'm not getting anywhere, but it is definitely geometric. Okay. 4 times 1 times 2, or 4 times 1, 4 times 1/4 gives me 1, but 1/4 of 1 gives me 1/4, so that is not geometric. Okay. And the last one, if I do 20 divided by 4, gives me 5. 4 times 5 is 20. 20 times 5 is 100. So this is geometric. And I want to go ahead, we're going to write the formula for this. We know our ratio is 5. So a sub n is going to equal, our first term is 4 times 5 to the n minus 1. And I wanted to do this just because I want to show you what happens if this coefficient isn't 1. So let's find the 10th term of this. Okay, so 4 times 5 to the 10 minus 1 is 4 times 5 to the 9th. So according to order of operations, we've got to do exponents first. So 5 to the 9th is 1,953,125. And if I multiply that now by 4, that's going to give me 7,812,500. So if you've got to follow order of operations to solve these problems. Right. So today we kind of looked at arithmetic sequences and geometric sequences, compared them, and then learned how to write a geometric and how to find the nth term. Hope you behave. Have a great day.